Good morning. This is part 1 of our review for reciprocating engine. Our topics for our discussion in reciprocating engine are the following. Introduction, which includes the definition of terms and principles. The reciprocating engine characteristics, classifications, construction, and operation. Also, we will discuss engine analysis and thermodynamic applications. In 1876, a German engineer named Nicholas August Otto developed the four-stroke internal combustion engine that converts chemical energy into mechanical energy. His development of the piston engine offered a practical alternative to the steam engine as a power source for mechanically operated machines. Heat engine is a device that produces power from heat generated during chemical reaction, while air is the working medium capable of changes in volume and pressure when subjected to an increase in temperature caused by combustion. The four strokes of a piston engine consist of induction, compression, power, and exhaust, which is also known as Otto cycle. It is a sequential process that takes place one after another, wherein each stroke is distinct and separate. The piston moves in a reciprocating motion within the cylinder. Before moving forward, I've listed several terms that we will be defining as we go along our discussion. We have the cylinder head, the crankshaft, intake valve, exhaust valve, piston, the piston ring, connecting rod, spark plug, crankcase, camshaft, and the cam lobe. First, let's discuss the piston. The piston is moving within the cylinder. It has rings that prevents the gases from escaping the cylinder in a timely manner, which is also attributed to loss of power. Here are some of the primary functions of the pistons. First is that it draws fuel and air into a cylinder. Second, it compresses the gases. Third, it purges burned exhaust gases from the cylinder. And lastly, it transmits the force produced by combustion to the crankshaft. The speed of a piston is maximum during the first and the fourth quarters of its crankshaft rotation. The temperature may exceed 4,000 degrees Fahrenheit and pressures may be as high as 500 psi or more. Parts of a piston. The piston head is the top surface. This is directly exposed to the heat of combustion. The piston ring, which I did not mark anymore, is a metallic split ring attached to the outer diameter of a piston engine. It serves as a seal in the combustion chamber, so that there is a minimal loss of gases to the crankcase. Also the ring grooves. This cuts into the piston's outside diameter to hold a set of piston rings. As many as 6 grooves may be machined around the piston. Top compression ring. This is the closest ring to combustion gases. It is exposed to greatest amount of temperature and chemical corrosion. The compression ring transfers 70% of the combustion chamber heat from the piston to the cylinder wall. The secondary compression rings. This is also known as the lower compression rings. It scrapes oil and prevents it from reaching the combustion chamber. It also provides a secondary seal to trap combustion gases and to aid in the heat transfer to the cylinder wall. It can be made of gray cast iron, ductile cast iron, high alloy steel, or stainless steel. The ringland is the portion of the piston between the ring grooves. Oil control ring. Its main function in the bottom piston groove is to scrape oil from the cylinder wall, meaning the oil control rings play a major part in regulating an engine's oil consumption. The wrist pin is a pin through the skirt of a piston in an internal combustion engine, to which the little end of the connecting rod is attached. The bearing at the other end of the connecting rod is known as the little end, and holds the wrist pin that is mounted in the piston. The snap ring. It is designed to fit into a machined groove, either on the side of a bore or on the outside of a shaft. This component reduces vibration and also retains two parts of an assembly. It can withstand axial loading. Connecting rod shaft. This is also known as the con rod. Bearings. It protects and supports the connecting rod or crankshaft, enabling it to spin freely in the engine. Connecting rod bolts. Connecting rod bottom end bolts keep the two halves of the bottom end bearing together. These bolts are subjected to complex nature of stress as follows. Tensile stress, which is the tightening of the knots, stretching the bolts and subjects them to tensile stress. This also helps keep the two components together under tension compression. Connecting rod cap. A rod cap is a removable section of a two-piece connecting rod. It provides a bearing surface for the crank pin journal. The rod cap is attached to the connecting rod with two cap screws for installation and removal from the crankshaft. The piston skirt. It helps align a piston in a cylinder. The piston base is extended to form the piston skirt. The piston pin boss. It connects the piston and the connecting rod. It must withstand extremely high loads in changing directions. The piston pin is mounted for power transmission in the pin bore of the piston and the connecting rod. The piston head designs. Most modern aircraft engines use flathead pistons. However, as an aviation professional, you should be familiar with all the piston head designs. Here I have 4 examples, which is the flathead, the recessed head, the concave head, and the dome head. All of this provide a moving boundary to the combustion reaction space, and thus enable useful work to be extracted from the combustion gases. Its movement also provides means for gas transfer and compression. Transfer cylinder gas pressure forced to a piston rod, or the small end of the connecting rod. This is an image of a campground piston. Its piston skirt has an elliptical shape. The campground piston. Pistons expand as they heat up. Due to the added mass at the piston boss, most pistons expand more along the piston boss than perpendicular to the piston boss. This results in an even piston and cylinder wear. One way to compensate for this is with a campground piston. A campground piston is machined with a slightly oval shape, that is, the diameter of the piston parallel to the piston boss is slightly less than the diameter perpendicular to the piston boss. Next is the piston rings. Here are several functions of the piston rings. It prevents leakage of gas pressure from the combustion chamber. Second, it reduces oil seepage into the combustion chamber. And third, it transfers heat from the piston to the cylinder walls. Piston rings are classified according to its joint configuration. I have here 3 samples that are commonly used in aviation, or rather in aircraft engines. The butt cut, the angle cut, and the step cut. The butt cut is often used on automotive seals and applications where some leakage is acceptable. The angle cut is often used for steam applications, while the step cut is a good bidirectional seal for many sealing purposes. So we also have additional piston ring joint configurations: the step seal, the sure seal, and the tri-lap seal. Piston rings commonly used on small engines include the compression ring, the wiper ring, and the oil ring. A compression ring is the piston ring located in the ring groove closest to the piston head. The compression ring seals the combustion chamber from any leakage during the combustion process. Compression rings prevent gas from escaping past the piston during engine operation and are placed in the ring grooves immediately below the piston head. Most aircraft engines use two or three compression rings on each piston. The cross-section of a compression ring can be rectangular, wedged shaped, or tapered. Oil rings, on the other hand, control the amount of oil that is applied to the cylinder walls, as well as to prevent oil from entering the combustion chamber. So we have 2 types of oil rings. First one is the oil control rings, and the second one is the oil scraper rings. This is an example of the oil control rings. So oil control rings, it is placed in the grooves immediately below the compression rings. Its primary purpose is to regulate the thickness of oil film on the cylinder walls. It also allows oil control ring, rather the oil control ring allows to remove excess oil and return it to the crankcase. Small holes are drilled in the piston ring grooves or ring lands. Next is the oil scraper rings. It is used to regulate the amount of oil that passes between the piston skirt and the cylinder wall. It is also sometimes called as an oil wiper ring. The piston pin. This joins the piston to the connecting rod. Piston pin classifications. Stationary. These are held tightly in place by a set screw that prevents movement. Semi-floating. It is retained stationary in the connecting rod by a set clamp that engages a slot in the pin. It only allows little movement. Full floating. This is free to rotate in both the connecting rod and the piston. These are used in most modern aircrafts. Next is the connecting rods. Connecting rods are also known as con rod. This is a piston engine, or rather this is a part of the piston engine which connects the piston to the crankshaft. Together the connecting rod converts the reciprocating motion of the piston into the rotation of the crankshaft. It serves as a link which transmits force exerted on a piston to a crankshaft. It is made of durable steel alloy, however aluminum can also be used for low-power engines. On one end of a connecting rod, it is connected to the crankshaft, which is also called as the crankpin end, while the other end connects to the piston, which is called the piston end. Three types of a connecting rod. We have the plain type, the master and articulated, and the fork and blade. Let's discuss first the plain type. This is commonly used in opposed and inline engines. The end of a rod attached to the crankpin is fitted with a cap and a two-piece bearing. The bearing cap is held on the end of a rod by bolts and studs. To maintain proper fit and balance, connecting rods should always be replaced in the same cylinder and in the same relative position. Next is the master or articulated type. This is commonly used in radial engines. This type of assembly has one piston in each row of the cylinder that is connected to the crankshaft by a master rod, while the remaining pistons are connected to the master rod by articulated rods. So this is an example of a master and articulated type connecting rod. So in this radial engine, where do you think is the master rod in this assembly? So here it is, the master rod. Last is the fork and blade type. This is primarily used in V-type engines. The fork rod is split at the crankpin end to allow space for the blade rod to fit between the prongs. So this is an example of a fork and blade type. Next is the intake and the exhaust valves. So let's define what a valve is. Valves regulate the flow of gases into and out of the cylinder by opening and closing at predetermined times in the combustion process. Each cylinder has one intake valve and one exhaust valve. The intake valve controls the amount of fuel and air mixture that enters a cylinder through the intake port. It also operates at lower temperatures than the exhaust valves. The exhaust valves allow the exhaust gases to exit the cylinder through the exhaust port. So this is an example of the intake valve and the exhaust valves. Aircraft engine valves are classified according to their head profile. Valves have several head profiles. So we have the flat head, the mushroom head, the semi-tulip head, and the recessed head. Some valves are fitted with metallic sodium. This reduces the operating temperatures during operation. The sodium melts and transfers heat to the valve stem, where the heat is conducted away by the cylinder head. When installed in an operating engine, the sodium melts. When the valve stem reaches approximately 208 degrees Fahrenheit, the melted sodium circulates naturally due to the up and down motion of the valve and helps carry heat from the valve head into the stem where it is dissipated through the cylinder head. Valve parts and seating components. The valve face. This is the portion of the valve that creates a seat at the intake and exhaust ports. The valve seat. It is a circular ring of hardened metal that provides a uniform sealing surface for the valve face. The valve guide. It is a cylindrical sleeve that provides support to the valve stem and keeps the valve face aligned with the valve seat. The valve spring. These are helical coiled springs that are installed in the cylinder head and provide the force that holds the valve face firmly against the valve seat. The valve spring retainer. This holds the valve springs in place. A while ago, I mentioned that engines operate in a sequential manner, which is the same thing with the valves. It opens at the correct time, and then it is held for a certain period before it closes again. Its operating mechanisms consists of a camshaft, the valve lifter or tappet, the push rod, and a rocker. The following are components in a typical valve operating mechanism. So we have the camshaft, the valve tappet. So the valve tappet is a mechanism that transmits the force of the cam to the push rod, while the push rod is a steel or aluminum alloy or tube situated between the valve lifter and the rocker arm to transmit the motion of the valve lifter. And lastly is the rocker arm, a pivoted arm mounted on the bearings of the cylinder head to open and close the valves. Just an additional information. A radial engine valve operating mechanism performs the same functions as the mechanism used in an opposed engine. Let's discuss the camshaft. So the camshaft is a device that controls both the input of fuel and the expulsion of exhaust fumes. It consists of several radial cams, each displacing the intake and exhaust valves, and is connected to the crankshaft via timing belt, chain, or gears. The cam lobe, it controls the valve lift, and there is a direct relationship between the shape of the cam lobes and the way the engine performs in different speed ranges. Next is the timing belt. This is also known as a cam belt, a part of an internal combustion engine that synchronizes the rotation of the crankshaft and the camshafts So engine valves open and close at proper times during intake and exhaust stroke. Next is a crankshaft. This is a rotating shaft. It converts the reciprocating motion of the pistons to rotational motion. It is commonly used in ICEs and consists a series of cranks and crank pins to which the connecting rods are attached. So the crankshaft is said to be the backbone of a reciprocating engine. Its main purpose is to transform the reciprocating motion of the pistons and the connecting rods into rotary motion to turn a propeller. A typical crankshaft has one or more cranks or throws located at specified points along its length. However, it must also withstand higher stresses. It is forged from a strong alloy such as chromium, nickel molybdenum steel. So this is an image of a crankshaft. Next is the parts of a crankshaft. So a crankshaft has four main parts, mainly the main bearing journal or the main journal, crank pin, the crank cheek or crank arm, counterweights, and dampers. Here we have the main journal, the crank cheek, the crank pin, and the dampers. So all crankshafts consist of a main bearing journal, one or more crank pins, and several crank cheeks. So what is the main journal? It represents the center line of the crankshaft, and it supports the crankshaft as it rotates in the main bearings. This is the center of rotation of the crankshaft. Next is the crank pin, also known as the crank journal. It is a mechanical device that serves as an attachment point which connects the crankshaft to the connecting rod for each cylinder. So it has a cylindrical surface to allow the crank pin to rotate relative to the big end of the connecting rod. To reduce total crankshaft weight, crank pins are usually hollow. This type of construction provides a passage for lubricating oil. So in addition, a hollowed crank pin serves as a collection chamber for sludge, dirt, carbon deposits, and other foreign materials. Thus, it is also called as the sludge collector. Next is the crank cheek or crank arm. It is required to connect the crank pin to the crankshaft. Counterweights and dampers. This helps balance the crankshaft. It relieves the whip and the vibration caused by the rotation of the crankshaft. The main purpose of the crankshaft is to transform the reciprocating motion of the pistons and connecting rods into rotary motion to turn a propeller. So therefore, it needs to be statically balanced and dynamically balanced. So what is static balance? This is a weight of an entire crankshaft assembly that is balanced around its axis of rotation. So once a crankshaft is statically balanced, it must be dynamically balanced as well. Dynamic balancing refers to balancing the centrifugal forces created by a rotating crankshaft and the impact forces created by an engine's power impulses. The most common means of dynamically balancing a crankshaft is through the use of dynamic dampers. Dynamic dampers are weights which are fastened to a crankshaft's crankshaft assembly in such a way that it is free to move back and forth in a small arc. So each time a cylinder fires, a pulse is transmitted into the crankshaft that causes it to flex. When the engine is running, the crankshaft receives hundreds of these pulses each minute and flexes, or vibrates constantly. To help minimize this vibration, the dynamic dampers oscillates, or swings, each time the crankshaft receives a pulse from the firing cylinder. These oscillations are opposite the crankshaft vibrations and therefore absorb some of the force produced by the power impulse. The main purpose of the crankshaft is to transform the reciprocating motion of the pistons and connecting rods into rotary motion to turn a propeller. Therefore, it is also important to know its different types. So the following are the types of a crankshaft depending on the number and arrangement of an engine cylinders. We have the single throw, 2 throws, 4 throws, and 6 throws. The single throw or the 360 degrees. This is commonly used on single row radial engines. As the name implies, a single throw crankshaft consists of a single crank pin with two main journals that support the crankshaft in the crankcase. A single throw crankshaft may be constructed out of either one or two pieces. Next is the two throws. This is commonly used on a twin-row radial engine with one throw for each bank of cylinders. The throws on a two-throw crankshaft are typically set 180 degrees from each other and may consist of either one of the or three pieces. Four throws. These are commonly used on four-cylinder opposed engines and a four-cylinder engine inline engines. A typical four-throw crankshaft used in horizontally opposed engine is machined as one piece with throws that are 180 degrees apart. Last is the six throws. This is commonly used on six-cylinder opposed engines and inline engines, and also for 12-cylinder V-type engines. The throws are 60 degrees apart on a typical six-row crankshaft. And also the crank journals are numbered from the flanged end. Next is bearings. Typical areas where bearings are used in an aircraft engine include the main journals, the crank pins, connecting rod ends, and accessory drive shafts. Bearings are used in any surface which supports and reduces friction between two moving parts, a part in which a journal pivots and the shaft turns or revolves. There are two ways in which bearing surfaces move in relation to each other, either by sliding movement of one metal against another or surface to roll over another. The three types of bearings, the plain, ball, and roller bearings. Plain bearings. These are generally used for crankshaft main bearings, cam ring, and camshaft bearings, connecting rod end bearings, and accessory drive shaft bearings. This is subjected to radial loads only. Here's an example of a good and a bad plain bearings. Ball bearings assembly consists of a grooved inner and out races, which has one or more sets of polished steel balls and a bearing retainer. The balls of a ball bearing are held in place and kept evenly spaced by the bearing retainer, while the inner and the outer bearing braces provide a smooth surface for balls to roll over. Ball bearings have the least amount of rolling friction. This is also suited to withstand thrust loads. Ball bearings. Roller bearings. It has a similar construction with ball bearings, except that polished steel rollers are used instead of balls. It provides a greater contact area and a corresponding increase in rolling friction over that of a ball bearing. The roller bearings has two types, namely the straight and the tapered roller bearings. The straight roller bearings are suitable when it is subjected to radial loads only, such as the crankshaft main bearings, while the tapered roller bearings allow the bearing to withstand both radial and thrust loads. So this is an example of the straight and the tapered roller bearings. Next is a crankcase. So it is the housing for the crankshaft. In most modern engines, it is integrated into the engine block. It is the foundation of a reciprocating engine, and it contains its internal parts and provides a mounting surface for the engine cylinders and external accessories. It is made of cast aluminum alloys. This is an example of a radial engine crankcase. A radial engine crankcase is divided into 4 distinct sections. The number of the sections can be as few as 3 or as many as 7, depending on the size and the type of the engine. So in general, a typical radial engine crankcase is separated into 4 main sections, mainly the nose section, the power section, the supercharger section, and the accessory section. Here are the 4 basic power delivery parts: the cylinder, the piston, connecting rod, and the crankshaft. Cylinders are also known as the power unit of the engine. It is a chamber where the avgas is burned and turned into power. An engine with more cylinders produces more power, while an engine with fewer cylinders gets a better fuel economy. Again, the cylinders provides housing for the pistons and the connecting rod assembly, as well as the valves and the spark plugs. It is the place where combustion occurs and gases expand to produce power. Cylinders also transmits power through piston and connecting rods. It is composed of the cylinder head and the barrel, or the cylinder barrel. The cylinder head sits above the cylinders on the top of the cylinder block. It acts as a lid on the barrel to provide enclosure. It closes on the top of the cylinder, forming the combustion chamber. It is sealed by a head gasket. It also provides space for the passage of fuel and air mixture to the cylinder and also allows the exhaust air to escape. The head can also be placed to mount the valves, spark plugs, and fuel injector. The spark plug. It is a device for delivering electric current from an ignition system to the combustion chamber of a spark ignition engine to ignite the compressed fuel and air mixture by an electric spark, while containing combustion pressure with the engine.